Hi everyone, this is Mr. H again, and welcome back to my YouTube channel. In this video, you will learn about derivatives of trigonometric functions. Alright, so before we begin, if you haven't watched the videos yet about part 1 and part 2 of derivatives, I recommend that you visit the link in the description box. Because this video is actually the third part. Alright, so just to give you an idea, part 1 of the video covers the differentiation rules and some examples. Part 2 covers the derivative of exponential and logarithmic functions, and this is the third part. Alright, so let's jump straight into the concept. So these are the things that you need to remember. So derivatives of trigonometric functions. Alright, so for the first one, we have the derivative of sine x with respect to x is equal to cosine x. Derivative of tangent x is equal to secant squared x. The derivative of secant x is equal to secant x times tangent x. The fourth one, we have the derivative of cosine x is equal to negative sine x. Derivative of cosecant x is equal to negative cosecant x times cotangent x. And the last one is the derivative of cotangent x is equal to negative cosecant squared x. Alright, so you really need to remember all these things because in differentiating trigonometric functions, you will be applying all of these. And in this video, we will be answering some examples. Alright, so without further ado, let's head on to example 1. Alright, so for example 1, we are asked to differentiate f of x equals 3 over 2 times cosine of 2 pi x. So differentiating with respect to x, all right? To begin with, so f prime of x equals, so we separate 3 over 2, and we get the derivative of outside. The derivative of cosine is negative sine. So negative sine, and the angle is 2 pi x. After finding the derivative of the outside, which next we need to find the derivative of the angle, and the derivative of 2 pi x is 2 pi. And then to get the final answer, we simplify what we got. So f prime of x is equal to, right, so this one, 2 divided by 2 is 1 and nothing more. So we write our final answer, which is negative 3 pi sine of 2 pi x. That is the answer. Alright, so you have to remember finding the derivative of the outside, copy the angle, and you need to get the derivative of the inside. Alright, so let's head on to example number 2. Find the derivative of y equals cosecant x minus x tangent of x squared plus 1. Alright, so by just looking at the given function, we can see that we can apply the difference rule of differentiating, which in short, what we need to do is to get the derivative of every term. Alright, so we'll have y prime equals derivative of the first term. The first term is cosecant x, so straightforward. And earlier from the list that I showed you, the derivative of cosecant x is negative cosecant x times cotangent x. All right, and then we copy the minus sign there. And now for the second term, you can see that the second term is x times tangent of x squared plus 1. It's very obvious that for the second term, if we are going to differentiate this term, we need to apply the product rule. And just to recall the product rule, say for example, x here is u, and tangent of x squared plus 1 is your v, right? And if you want to find the derivative of that, so what we need to do is we take u times the derivative of v plus v times the derivative of u. All right, so let's begin differentiating the second term. So we take x times the derivative of tangent is secant squared. And then we copy the angle, x squared plus 1. It's called either the angle or the argument of the tangent function, so which is x squared plus 1. But remember to find the derivative of the inside, which is 2x. Plus, we take the second factor, which is tangent of x squared plus 1, times the derivative of the first factor, which is 1. And we simplify. So for the first term, we just simply copy negative cosecant x times cotangent x minus, we can simplify what's inside the bracket first. So here we can see that x times 2x is 2x squared. And then we copy secant squared of x squared plus 1. And from here, we can just simply copy. If there's nothing that we can simplify anymore from here, then this is going to be negative cosecant x cotangent x minus 2x squared secant squared of x squared plus 1 minus tangent of x squared plus 1. All right, so if there's nothing that can be done anymore here in terms of, simplifying, combining like terms or what, so that means that will be the final answer. All right, so it basically depends on how the answer must be presented. Whether it's in factored form or expanded form, we consider them right because either of them is correct. All right, so if you're enjoying this video, give me a thumbs up. And if you haven't subscribed yet to my YouTube channel, please hit the subscribe button and hit the notification bell so that you won't be missing my future videos. All right, so let's take a look at example number 3. All right, so for example number 3, we are asked to find the derivative of g of x equals 1 divided by tangent x plus 4 divided by cosine x. So for this one, I would like to rewrite the original function, okay? So g of x, so I would say that 1 divided by tangent x is actually the same as tangent x to the power of negative 1. All right. So recalling rules of exponent. But you really need to be careful because it should be tangent x to the power of -1, not the inverse, okay? So tangent inverse of x is different from this one. So plus 4 divided by cosine x. So I would say 4 times cosine x to the power of -1. After rewriting, then we can proceed with differentiating the function. So g prime of x, differentiating each term. All right. So tangent x to the power of -1. So we'll have -1, take the base, so tangent x, then we subtract 1 from the exponent. And remember, so chain rule, so to get the derivative of tangent x, and the derivative of tangent x is secant squared x. So that's the derivative of the first term. Now we move to the derivative of the second term. So first, power rule. So it will be, so 4 is already there. Then -1. So that's times -1. Then we take the base, so cosine x. And remember to subtract 1 from the exponent. And chain rule, get the derivative of cosine x. And the derivative of cosine x is negative sine x. And then we simplify. So g prime of x equals, okay, so -1. So tangent x to the power of -2 times secant squared x. And for the second term, we'll have, okay, so we have negative times negative is positive. So it's positive here. And we have, so 4 times cosine x to the power of -2 times sine x. After this, you can take a look at each term and maybe we can do something to simplify it. It will be negative, so -1 times secant squared x, so negative secant squared x. And we put down this one. This one has negative exponent, and applying the law of exponent, we can put it down. So that will be tangent squared x. And for the second term, so plus 4 times sine x is 4 sine x divided by, so again, we can put this down and change in order for the exponent to become positive. So that will become cosine squared x. All right, so g prime of x. So negative, so secant squared x can be rewritten into 1 over, or 1 divided by cosine squared x. So divided by tangent squared x can be rewritten as sine squared x divided by cosine squared x. And for the second term, it's already it. So we just copy 4 sine x divided by cosine squared x. All right. And you can see that for the first term, if we perform the division here, definitely something will be canceled out, right? So let's work on that. So I'm going to be writing it here. So we take the numerator, -1 divided by cosine squared x. And for the denominator, which is sine squared x divided by cosine squared x, we need to get the reciprocal of that. And the reciprocal of that will be cosine squared x divided by sine squared x. And after getting the reciprocal, we proceed to changing the operation to multiplication. And you can see from here that cosine squared x divided by cosine squared x is equal to 1. So technically they're cancelled out. And we are left with -1. Okay, so 1, 1. So -1 times 1 is -1. Divided by 1 times sine squared x is sine squared x. So technically, this term right here can be rewritten as this. So that's -1 over sine squared x. So we can replace it. All right, so the first term is actually equal to -1 over sine squared x. Right? This is the answer. This is the derivative. So maybe some of you will be thinking that, oh, so -1 divided by sine squared x is actually equal to negative cosecant squared x. That's also okay. All right. So then again, it will always be dependent on how you are asked to write the final answer, because answers can have different forms. So we say alternate form of this answer. All right. But technically this one is already the derivative. All right, let's head on to our last example. All right, so example number 4, differentiate y equals secant squared x divided by square root of x plus 1. You need to rewrite the function if you're going for the product rule, right? So if you're rewriting this as y equals secant squared x and putting up the denominator square root of x plus 1, so it's going to be x plus 1 to the power of -1/2. If you're rewriting it this way, definitely you can go for product rule. But if you're going to stick to how the function is originally written, like here, then quotient rule is your way to go. All right. So since we haven't applied quotient rule yet in this video, then we'll go for quotient rule for example 4. All right. Now let's recall quotient rule. Once again, if you haven't watched the very first video about derivatives, I recommend that you watch the video, because that video includes the rules in differentiating. All right. So let's go back to the example. So I was mentioning about quotient rule. All right. So say for example, the numerator here, secant squared x, is u, and the denominator is v. All right. And if you want to go for quotient rule, definitely the rule that you need to follow is we take v times the derivative of u minus u times the derivative of v divided by v squared. So let's begin y prime, so we take square root of x plus 1 times the derivative of the numerator. So we're going to have 2 times secant x, and the derivative of the inside is secant x tangent x. All right, minus, we take the numerator, which is secant squared x, times the derivative of the denominator. So you can rewrite this as x plus 1 to the power of 1/2. So the derivative of the denominator is 1/2. So apply the power rule first. So 1/2 times x plus 1 to the power of 1/2 minus 1. And remember, chain rule, so derivative of the base. So derivative of x plus 1 is 1. So times 1 divided by the square of the denominator. And then what we need to do next is to simplify, obviously, the numerator. So y prime equals, so let's simplify first this part. So we copy a square root of x plus 1. All right, so we copy 2. Secant x times secant x is secant squared x. And then we just simply copy tan x. Minus, we simplify what's inside the bracket. So we can see here that, all right, we'll have 1/2. 1/2 times 1 is 1/2. And then secant, we copy secant squared x. And this one needs simplification. So we simply copy the base, x plus 1. And 1/2 minus 1 is negative 1/2. All right, so remember the denominator. All right, I suggest not to expand the denominator because later on we can simplify the numerator, this whole thing right here, by applying the factorization. All right, and maybe something can be canceled out. So let's continue simplifying. So simplify the numerator. All right, so we've already simplified everything inside the bracket and the parentheses, right? So this one right here is, the entire thing here is the first term. All right, and this entire thing right here is the second term. And now, as part of the simplification process, we can apply factorization by taking out their common factors, okay? So expressions that are common in each term, all right? So by looking at the two terms, we can see that square root of x plus 1 is actually a common factor, because if you're going to rewrite this, it's actually x plus 1 to the power of 1/2, right? So, and you also have that factor here. Though it's negative, though its power is negative 1/2, definitely if we take out square root of x plus 1, something will be left here, right? So we can take out square root of x plus 1. So another factor that you can see is secant squared x. So both terms have secant squared x, so we can take that out. all right? And by taking out square root of x plus 1 and secant squared x from each of the terms, we will be left with something, right? And those will be part of the second factor. All right, so if we take out square root of x plus 1 and secant squared x from this term, we will be left with 2 tangent x. And taking out square root of x plus 1 and secant squared x from this term, so remember the negative sign here, we will be left with 1/2 and x plus 1 to the power of -1. Because if we multiply this and this one, if we're doing the reverse process, we will be arriving at this product. All right, and remember the denominator. We can, okay, split that. All right, and as you can see, we can cancel out, right? So square root of x plus 1 from here and this one. And we are left with y prime equals secant squared x times the whole thing inside a bracket, so which is 2 tangent x minus 1/2 times x plus 1 to the power of -1, and the denominator now is square root of x plus 1. The next thing we need to do is to simplify what's inside this bracket. So I will write the simplification here. When I mean simplify, we can rewrite this whole thing as a single fraction. All right? And by just looking at it, definitely this part needs to be rewritten. So we'll have 2 tangent x minus, so that's a negative exponent there, -1. So that means we can put it down. So it's 1/2. That's the 1/2 there. And putting down x plus 1, the exponent will become positive. All right? And from here, we can rewrite this whole thing as a single fraction by doing this. So this denominator needs to be multiplied by this. So 2 times x plus 1 times 2 tangent x is, okay, so let's rewrite that. 2 times x plus 1 times 2 tangent x. Then -1, we copy, divided by 2 times x plus 1. All right, we can simplify this part. And that will be, so 2 times 2 is 4. Then we copy x plus 1. Then we copy tangent x. Copy -1 divided by 2 times x plus 1. All right, and now this is a single fraction. All right, so that means this whole thing is actually equal to this one. Okay, so let's rewrite it. So we'll have y prime equals secant squared x times this whole thing right here. And don't forget, the denominator is square root of x plus 1. Oh, we can see that we can perform now here the operation, division, right? Okay, but before we do that, let me erase. All right, so y prime equals, so we take the numerator and then we take the denominator, get the reciprocal of that, and shift to multiplication. And then from here you can see multiplying this times the numerator is going to be the same, divided by, so multiplying the denominator here and here, we can see that we can combine x plus 1 and square root of x plus 1. And by multiplying them, it will give us 2 times x plus 1 to the power of 3 over 2. Because 1 plus 1/2 is 3/2. All right. Actually, this is the answer. Right? That's in factored form. But if you want to perform the distribution property in the numerator, you can also do that. That's all for this video. If you learned something new, please give me a thumbs up. Please share the video as well. And if you haven't subscribed yet to my YouTube channel, please do so. And do not forget to hit the notification bell so that you won't miss any of my future videos. And once again, this is Mr. H, and I will see you in the next one.